All right. Well, good morning, good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Gabreski, and I'll be your host for today. If you've been with us since the beginning of the month, we are celebrating space exploration. So, talking to astronauts and scientists and engineers and researchers who are exploring not only in our solar system and beyond, but also looking back at our planet and how it's changing. And what we should be thinking about with things like climate change. So if you visit, there's still lots more events coming up. If you visit our website at exploringbytheseat.com, under the event section, you will find space exploration listed there, and all the events are there. You can register and join us for some of those events that we have going on throughout the month. So today's speaker is a friend of Exploring by the Seat of Your Pants. She has joined us for several of our October Space Week and Space Month events. We've got Debarati joining us. In the past, she's joined us as a member of the Mars Science Laboratory team studying rock chemistry and habitability of the planet Mars using the Curiosity rover, so using a laser instrument to measure the element boron in the Gale crater on Mars. She's currently now working for Los Alamos National Labs and is working on how we can extract lithium with a lower carbon footprint. And some of you may know that lithium is really important as we make a switch over to batteries, to more electrical power and having those batteries. So how can we extract that lithium in a way that is a bit less invasive on the planet? So let's bring Debarati in live right now. Hey, Debarati, how you doing?
Good. How are you guys?
Good. Well, it's great to have you with us. Usually we're hanging out in Canada, but now you've got a little bit of an adventure, a new career on the go.
Indeed. Yeah, we are in the high desert now from the boreal forest. It's a big change. So still happy to be here. Very excited.
Oh, absolutely. Well, it's great to have you with us. We've got classrooms joining from across Canada and the US. Some of them are already saying hi in the chats as well. We'll have some classrooms on camera with us soon. And then we're going to play a little Kahoot. While you're presenting, I'm going to make a little Kahoot quiz for the classrooms, and we'll wrap up with Q&A.
Fantastic. Sounds great.
All right. I'm going to let you take over for a little bit.
All right. I am going to share my screen. And here we go.
All right. I see it loading up.
How are we doing on the share?
We're full screen and good to go.
Sweet. All right. So is everyone ready for a trip from Earth to Mars and back? If so, let's start. Hi, I am Debarati. I am a postdoctoral researcher at Los Alamos National Laboratory in New Mexico, which is in the US. And I have been a NASA Mars Science Laboratory team member, still working on looking at these squiggly lines on Mars, which are basically veins filled of salty material. And I'm using the Curiosity rover. I am a part of the team that uses the Curiosity rover to analyze rocks in Gale crater. I'm also a National Geographic explorer. I went to Death Valley to look at rocks that resemble stuff on Mars. And please ask me all the questions you have. So my path all the way up to here has been high school in India. I got my bachelor's degree and my first master's degree in geology and earth sciences in India. I moved to Japan after that. I got my second master's. I studied meteorites and extraterrestrial material there. And after that, I moved to Canada to do my PhD on Mars rocks, chemistry of Mars rocks. And I finished last year, woohoo. And now I am here doing a postdoctoral research, still on Mars, but also back to Earth at Los Alamos National Labs. And this is a part of the team that I work with, an excellent team full of brilliant scientists who are absolutely inspiring. And this unit right here is a chamber that is similar to, is basically a similar instrument that we have on Mars. And we use this to shoot lasers here on Earth to check what it looks like on Mars. So before we get started, let's take a virtual field trip to Mars, basically. Let's look at the field area that I've been on for the past 5 years. but virtually. So I'm using Google Earth for this. So you can feel free to go and explore Mars yourself. Google Earth has this really cool feature where you can look at the sky, you can look at Mars, you can look at the moon, and some really detailed images of them. We're going to zoom in on a specific crater on Mars called Gale crater. So here we go. We're zooming in. As we zoom in, you're going to start seeing all these names pop up, which are basically names that scientists have given to classify different areas. And here we see this gray area that shows up because we have really detailed images of these features using the Mars orbiters. And here's the landing ellipse where Curiosity rover aimed to land at. It ended up landing at Yellowknife Bay, which is pretty good. It landed in 2012, August 2012. So it's been going strong for 11 years now. And you see this red line, which represents the path that the rover has taken. And it's not really, this rendition is not updated. And right now, the rover has reached all the way up to here in this V region. And as we keep zooming, you see these beautiful features, these beautiful layers and ridges and ripples on the right side. And you can't help but wonder, like, here are some of the features that we've also seen on Earth. Maybe if you've gone on a hike by a lake, you see all these features on sandy areas, and you can't help but wonder, what are these processes that are happening on a completely different planet that resemble so much of what we have already seen on Earth? And as we zoom out, we're starting to see the central mound, which is known as the Mount Sharp region. In a little bit, I'll talk about it, but let's bid adieu to our planetary field trip for now. So if you look at the crater again, this is the reference of where the rover landed, and the approximate size of the whole crater is about 145 kilometers. So when you're thinking about that from Earth scale, that's approximately the size of one of the biggest Hawaiian islands. So it's pretty large. And when you look at the central mound that I was talking about, that is informally known as Mount Sharp, it's about 5 kilometers high. And based on observations, we know that this is made out of about 5 kilometers of sedimentary rocks, which we hypothesize has formed because there was long-standing water here that over a really long time laid down this material that rose up to 5 kilometers. So where did I start here in terms of my research? I started with the analysis of water-soluble elements with a special focus on the elements boron and lithium on these veins that we observed in Gale crater on Mars. We also have similar veins on Earth, which is really helpful for us to understand how these things formed on Mars. Here down below, you see this image. This is actually from Gale crater on Mars. So I studied the data using the laser instrument on the Curiosity rover to understand past water activity on Mars. So why choose boron and lithium? Because these two are very light elements. Boron is the 5th element on the periodic table. Lithium is 3rd, and these are extremely light, and they are very fast movers. They like water. They travel really fast in water. So they're almost like proxies for where is the water going. And that's really good for us because it helps us know all the nooks and crannies the water went to. For example, if you look at this image over here, what likely happened is some water that was enriched in salty material, salts that can consist of salts made of boron, which could be borates, or lithium is a little bit more, it becomes liquid very fast, so it might not be here. But salts, for example, like table salt, sodium chloride, can get mixed up in water and can get injected into these nooks and crannies of rocks, and it can help us know what's happening there. And when we study these salts, it also helps us understand what could have been the condition of the water, what could have been the chemistry of water, what could have been the environment. And all this information is really key for understanding, was life possible on Mars? What was it like on Mars when there used to be liquid water? Another reason why we also selected boron is because in 2016, for the first time, we discovered boron in these vein-like materials on Mars. So we already have this. Why not look at lithium and see what information it has to tell us? So again, this is the material. This is what it looks like on Earth. It's called gypsum, a common component of plaster of Paris, if you have interacted with that. So how do we measure boron and lithium on Mars? With lasers, of course. Here is the Curiosity rover, and the head of the Curiosity rover is known as the ChemCam unit, chemistry camera. And on that, there is this instrument, the acronym for which is LIBS, and that stands for Laser Induced Breakdown Spectroscopy. So what does this actually do? Basically shoots a really high-powered laser onto your area of interest, which can be a soil or rock. And this is actually a stop motion that has been developed based on the images that we have received from Mars. The beam size, you can see, is quite small. It's about 200 microns. So just when you put a few strands of your hairs together, that is the diameter of this laser. And this laser turns this material into plasma. And when this plasma cools down, it gives this characteristic fingerprint of wavelengths that tells us what is the chemical makeup of this rock. And this is how we understand what is the chemistry of different rocks on Mars. So what are we really measuring when we are measuring these squiggly veins full of salt? This is where terrestrial or Earth analogs, analog being something that is similar to that on Mars, helps us. So if we look up here are the veins that we also see on Mars. And how do they on Mars and on Earth? So how do these form? They don't always form like this. In fact, these salts or evaporites, we call them evaporites because they're formed because of evaporation of water. These veins, we call them as secondary evaporites. Let's look at how it forms on Earth. If we look back, their origin story is they form as these crusty materials when dry lakes are evaporating. Dry lakes are also known as playas. In areas like Death Valley or Argentina and Chile, there are these dry lakes. When they evaporate, they leave this layer of crusty, salty material. And they don't immediately form veins like this. The process through which these veins form, we think, is because rain will fall on this salty stuff, it'll dissolve it, and then eventually soak through the earth to form groundwater. And this groundwater will get injected through cracks of rocks to form veins like this. And it's super helpful to have features like these available on Earth. Earth is a great classroom for what physical and chemical processes can take place on other planets. So this is what we aimed to do on Mars. We don't really have a geologist yet, but we tried to see where are these areas where we can see similar features. And when we compare these features on Earth and Mars, they are pretty similar in terms of physiology. So here we are. I chose Death Valley as my field area, my alternate field area, to understand these features a little bit more. Here I am collecting these veins, which to my delight look very similar to what we have seen on Mars. And we collected a whole bunch of samples. And an advantage of having these features on Earth is that we can actually hold this. There are certainly a large number of limitations when we are working with when we're working remotely on Mars with a robot. We can't just go to a place, look at the sample to our heart's content, hold it, get all the rocks around it to understand really what is the relationship between the salty stuff that formed when water dried off. So we collected a whole bunch of samples, we ground them up, made them into pellets, we shot them with lasers, and look how happy I am because I get to actually hold a representative of these samples and understand what exactly could be the formation processes of these salty materials, and what did it tell us about the aqueous conditions on ancient Mars. Before I get into what we learned from this, I want to have a very fun sidebar on how full of life a place like Death Valley is. It's called Death Valley because it gets really hot and it's a desert, and it is also a Mars analog. But honestly, the the sheer number of ways life manifests in this area is just mind-blowing. The different kinds of wildflowers, all colors, shapes, and sizes, the different kinds of lizards and fish that don't even require a very lush living condition. You see this very little stream of water. The pupfish are up and running in the months of May and April, and the water dries out after that. They lay eggs and they die, and that's their yearly cycle. They come year after year, and life just finds a way. And when you take a step back and you look at the Badwater Basin in Death Valley with all the salty material that has kind of accumulated where water once flowed, you can't help but wonder, what are the processes on Mars that have taken place? What are the seasonal cycles? Is this how life originated? Is this basically a big pot for where life started on Earth? Some of these questions led to the other parts of my work. The third part of my research was to thermochemically model what could have happened on Mars. So on Earth, we know that a lot of seasonal cycles affect the rocks and help the formation of things like rivers and lakes. And we wanted to simulate that for Mars. So we simulated a Mars lake with math, chemistry, and geology, basically. We have the rock composition from Mars, based on the data that we're getting from the rover. And we have a best estimate guess for what the water on Mars could have been like. And we simulated these seasonal cycles of dry and wet, like summer, winter, a monsoon, to see what do we get? Do we get the salts that we're expecting on Earth? So that was also a very interesting part of my research. So overall, when we were doing this research, what did we learn? We learned that a lot of the minerals, for example, if we're trying to make this stuff, we need all the minerals in our toolbox, in our theoretical toolbox. We identified a lot of data that is not yet there to theoretically model effectively what could have been present on Mars. We learned a lot. We still did get some results that helped us understand maybe a time period over which this could have happened. We learned a little bit more about evaporites would behave on Mars, which is really useful because Curiosity rover's path right now is leading up to an area which is called the sulfate bearing unit. Sulfate is an evaporite, it's a salt. So we are going towards an area which has a whole bunch of salts. So if we know from math, chemistry, and geology what we should expect, that's really, really helpful. So looking forward, after bringing together Mars observations, Earth observations, and theoretical modeling results, we found out that these results are not applicable just for Mars, but also for Earth. Through this research, we kind of understood a little bit more about the behavior of lithium and how lithium would behave in underground fluids or groundwater that injects through different parts of topography to form these veins. And this was really a really useful idea because lithium is an important component of lithium batteries, which help us store energy in rechargeable batteries, which is awesome for us. We're not using coal to form energy, but predominantly the lithium so far has been mined out of hard rocks, and hard rock mining has a relatively high carbon footprint, as in it's creating a relatively high amount of carbon dioxide and contributing to pollution. So one method of lithium extraction that is more eco-friendly is lithium extraction from geothermal brines. It has a lower carbon footprint. And when we model mathematically what is the behavior of lithium in these geothermal brines, we understand a little bit more about how we can extract this in more eco-aware investigative techniques. So this is one of the applications of some of the space work that I have done, and it's just very quickly becoming a passion project. So I'm very happy about this, and I'm hoping that we get some good results from the research that I'm doing. And some of the research that I'm doing here, it consists of filling the gaps in theoretical modeling database through measurements, and I'm testing more Mars analog samples. Here's the Chem engineering unit at Los Alamos. Here's me for scale. I'm very happy about this picture because usually people don't get to see inside our lab, and we had the opportunity to take these really cool pictures with some of the instruments that we work with. So I'm very happy to be able to share it. Another new part of my job is to train to operate the rover and selecting rock targets to shoot with the laser. I also get to name them, and I'm still a trainee, but I'm really enjoying the process. And I wanted to give you guys a little sneak peek, or rather things that I can actually share with you. So this is available on the public domain, and this is basically kind of what operations on Mars looks like. We have this every time when there's Mars operations, we have this images. We have a bunch of images from Mars, and we can see the outline of the rover. We don't want to shoot the rover. We want to be pretty safe, and we have an area where we can look at all of Gale crater. We can look at the crater rims, and this is a really nifty tool which kind of resembles what we do on Mars during operations. And you can look at the different areas. You can click on a rock, and through this tool you can see what it actually looks like. So it gives you a feeling of what rock target piques your curiosity. Like, this is a rock target that you think is really cool. Maybe we should shoot this with the laser. Or maybe let's look at something else, maybe this area. And that's what that looks like. You can still see these really cool little veins running through them. Every time I look at this tool, it makes me really excited, because this is kind of what our job looks like. And it's so exciting to see all these images from Mars and be able to see all these little veins and cracks that resemble stuff that we see on hikes here. And you can't help but wonder that, wow, these two planets are so similar yet so different. Another really cool feature of this this thing is you can open a map view, and it tells you exactly where the rover is. So you looked at the Google Earth view, and it hadn't quite updated, but this one quite accurately tells you the rover is right here, and you can zoom quite far into this image to see what the features actually are. You can see all these little ripples and all kinds of layers. So I hope you guys sort of check this out and get some of your questions answered about your curiosity regarding Mars. Well, going back to the slides, in addition to Mars science, I always like to talk about my other hobbies. I'm a scientist, but I also care a lot about art. And I love learning about sustainable foraging and nature and spending time on things that I love. This is really, really important. And it's very grounding. So it's important to have a balance between science and all the other things that we love. And my interest in art has kind of like merged with my interest for space. And recently I've been making a lot of space art, and it has been really fun. And it also helped me take advantage of this opportunity where I was able to show some of my art for the largest exhibition in space. We submitted some of our artwork, and the artwork was printed on the side panels of a satellite, and that was launched. So that was really awesome. And my interests have also kind of like flown over into making clothes that shoot lasers or have a glowing galaxy. So just because you are interested in science, it doesn't mean that you have to be limited to science. You can be literally anything. So if you like space science, you can consider becoming a scientist, an engineer, astronaut, science communicator, science journalist, museum curator, artist, fashion designer. I know some musicians who have taken sound bits that we have received from Mars and turned it into music. And these are all real people. Some of them are my friends. Dr. Nina Lanza is one of my mentors, and these are just awesome things that you can do if you like space science. And with that, I will stop my presentation and take questions.
All right, Debarati, thank you so much for a great presentation. Those links that you shared with us, I will share those with the classrooms after so they can do a little exploration themselves and see what Curiosity's up to and explore some of those rocks. Now, in just a moment, we're going to get to a little Q&A action. But before we do, I pulled together a quick Kahoot quiz while you were presenting. So we're going to have the students have a little Kahoot action. So give me a second here to share my screen. Okay. So if you want to play along, you can go to kahoot.it. And then it's going to ask you for the pin 6520542. If you have one-to-one tech, maybe you have a tablet at your desk or a Chromebook, you can jump in that way. Otherwise, your teacher could pop it up at the front of the room and you could shout out your answers to him or her. Or if you can't connect, well, you can still play along and see what your score would have been, see how you would have done. So we'll give a couple seconds here to get some questions, to get some students and some classrooms loaded in. There's 5 questions today. Some are true and false, some are multiple choice. 20 seconds for each one. The quicker you answer, the more points you're going to get if that answer is correct. While some students load, we've got Miss Paterberg's class joining us from Kansas City, Missouri. They're on YouTube, and they're wondering if chemistry is important to study geology majors. So did you add that to your studies later on, or were you doing that right away?
No, it's not important to have chemistry right away. You will pick that up once you get into it. The reason I went into geology was because I wasn't the best at math. So, but it came in later anyway. And so you don't technically have to take any certain major to start studying space science. We have majors from computers, math, engineering, science. We even have people who have taken literature who help with science communication. So you don't particularly have to have a certain major. It helps to have geology and chemistry or physics, but either way, if you have any sciences, that's a big plus.
All right. So we still have a few students trickling in, but I think we're going to get started because we want to get into some Q&A action before we wrap up today. Also, a shout out to Ms. Pollock's crew who are joining us. They are joining us. They were on a camera spot, but had to switch to YouTube. So if you send your questions into the chat from Virginia, we will get some of those worked in. But let's get into our Kahoot action now. Okay, counting us in here. We have 3 seconds, and then we will be live. All right, our first question. Which crater is Debarati studying on Mars? Was it Fram, Airy, Gale, or Bar crater? Which of those 4, all 4 are craters on Mars, which one is the one where Curiosity is making its way through? A couple more seconds. All right, good job, crew. Overwhelmingly, we went with Gale. Okay, the Amusing Orcs is in first spot. Let's see what happens with our next question. Mount Sharp is about blank kilometers high. Was it 3 kilometers, 5 kilometers, 7 kilometers, or 9 kilometers? So Mount Sharp, was it about 3, 5, 7, or 9 kilometers high? Still a little bit of time to get your answer in. All right, good job, crew. It is about 5 kilometers high. The Lively Bear has snatched that top spot. A true and false one in here. Boron and lithium help us understand more about water on Mars. Is that true or is that false? Now, boron and lithium help us understand more about water on Mars. True or false? The quicker you get your answer in, the more points you get if that answer is correct. All right, it is true. Oops, there we go. Our leaderboard. The Lively Bear is holding on. We have another true and false coming up. The laser turns the sample material into liquid. Is that true or is that false? So the laser, is it turning that material into a liquid so it can be analyzed better, or was it something else? True or false? Is it a liquid? Couple more seconds. Ooh, a little bit of a split there, but the false took it because it is actually plasma, which on Earth, I think our northern lights, I think fire is a good example of a plasma material. The nimble lobster has made their way in there. One more question. What is a Mars analog? Is it a device on the Curiosity rover? Is it what we call life on Mars? Is it the name of a crater on Mars? Or is it a place on Earth that we can study similar to Mars? So what is a Mars analog? About 4 options there. Okay. Ooh, a split between a device or a place on Earth similar to Mars. It is a place on Earth similar to Mars. So we've had scientists on before who are out in the Atacama Desert in Chile, which is another great Mars analog here on Earth that we can study. Okay, let's see our podium. In third place, we've got the Eager Unicorn. In second, we've got the Expert Elephant. And in that top spot, holding it down, oh, the Amusing Orc sneaks back in from the very beginning. Very, very cool. All right, crew, thanks for playing along with us. Let's get into a little Q&A action now. Just come back from my screen share. All right. So if you are tuning in via YouTube, use that chat sidebar. For now, though, let's go to Florida and let's grab Mr. LeVogue's astronomy class hanging out with us today. How are we doing, Florida?
We're doing great. Hey, Dr. Doss, we finished first, second, and third on that Kahoot.
Woo! Congratulations.
Yeah, we were excited about that. We have a question for you. The first question we have, I saw in several papers that kids filled out, was what made you want to do the work you do now? What made you fall in love with rocks?
It's because I can go outside and touch them and get curious. You see these different colors of rocks. You see these veins running through. You're not sitting, indoors or having to do homework. That was my pull. You can go touch it. You can explore it. You go hiking outside, and rocks are cool. Put them in your pocket.
All right. We're going to come back your way, Florida. So have another question on deck. But now, where should we go now? We are going to go to some 6th graders hanging out with Mr. Murphy. Let's get them in here front and center. Here they come. Hey, 6th graders. All right. I see a NASA shirt there.
So excited.
Cool. All right. Let's get that mic unmuted and let's grab a question.
Does anyone have a question?
Peter!
Spiro?
How do the craters sort of change? Like, not the craters, but like the color on Mars sort of change?
How does the color on Mars change?
How does the color on Mars change? That's a really interesting question. It's kind of the same way color on Earth changes. So the way, if you look at iron and if you leave it outside, the color changes to red. So overall, if you take that logic and extend it to Mars, why is Mars kind of red? Because it's enriched in iron. And we do see areas that are a little bit more gray, a little bit more red. So it tells us a little bit about the atmosphere on Mars. It tells us about oxidation. It tells us about reduction. So that's actually a really important question to understand what processes could have taken place on Mars. It's because of the atmosphere that Mars is interacting with.
All right. So Miss Cornett's class is joining us. They were having a little bit of trouble and might have had to switch over to YouTube, but they're from Toronto, some grade 5, 6s. Let me see if they can hear and see us. Hey, Miss Cornett's crew, can you guys hear and see me? They might be on a 10-second delay because there is a 10-second delay between here and YouTube. Oh, there they go.
They can see it.
So they can. There is a little delay. Miss Cornett, do you want to try and unmute your mic? And let's see if you can hear, if we can get a question. Try and hit the unmute for us. Otherwise, you can type it into the chat. That's fine too. Oh, you're causing lots of excitement in classrooms today, Debarati.
I'm so glad to see this. Mars is exciting. Rocks are so exciting.
Okay. Are you able to unmute, Miss Connor? If it doesn't unmute, that's fine. Just click your...
Okay, yeah. We unmuted. Say hi.
Hi, everyone.
That's
All right.
amazing.
Do you guys have a question for us?
No, we don't. Sorry.
Okay. No worries. If you do change your mind, put it in the chat so I know to come back to you guys. Okay, Miss Forsyth's crew, where are they joining us from today? They are in Bracebridge, Ontario. So let me bring them in front and center here. Hey, Miss Forsyth, how are you?
Good. How are you?
Good.
We've got Kai here with a question.
Great.
How long does it take for a signal to go to and from Mars?
That's a fantastic question. I would say give or take a few hours because we do rover operations quite frequently, and the next day you can check if the satellite has passed overhead, and it tells you how many MBs or GBs of data that has been downloaded. So yeah.
Yeah, and what was the longest time that it took that you can think of?
What's the longest time it took to download the data, or
To get the signal.
To get the signal.
to get the signal? I think it's quite fast unless there's some sort of a uplink or downlink error, or if there's snow on the satellites. So it depends on the health of the satellites from here. The big dishes that we have, there was a recent problem when there was a snowstorm. I think I don't remember if this was in Arizona, and there was an unusual amount of snow coverage on the satellites, and it delayed getting some data in.
We know all about snow up here in Bracebridge.
Wonderful.
Very, very much.
All right.
Thank you.
Great
I was
question. All right, camera crews, get ready. We're going to visit you again soon, but I want to go to a few from YouTube here. So our high schoolers in Virginia, they would like to know, let's see. Oh, are you the one who's able to direct the actual laser, or did someone do it for you when you if you make a request? Oh, I think you froze for a sec. Can you still hear me?
Yeah, I can hear you.
Okay. So our high schoolers in Virginia were wondering, do you put in the command to use the laser, or do you direct someone else to do it?
So we are a whole bunch of people on the team. I am training for something that's called the uplink lead. So yeah, we do decide that these are the targets that we're going to hit. We choose the names, we explain why it's happening, and then we hand over this plan to the engineers, and the engineers sort of put it in where it's going to go, when is the instrument going to start. So technically it's a team effort where the scientists are deciding what to shoot and when to shoot it and how to shoot it, and the engineers are actually putting on the command in onto the rover so that the rover can operate.
Okay. Another question here from a student. Do you know if your team or any other teams have found any formations, geological,
that help us get closer and closer to finding out there are hydrated minerals, that water could have been possible on Mars? Then there's the discovery of organic materials. We haven't found anything quite like, a skeleton or fossils on Mars yet. But then again, our definition of life is limited based on what we see every day on Earth. So we're still chipping away at that question, and we are very hopeful that we're going to get closer to the answer. But to answer your question, in a short way, not yet, but I think we're going to get there soon.
All right, one more from YouTube, and then we'll visit our camera crews. Madame F would like to know, what inspired you to bring art into your science life?
I think I was an artist before I was a scientist, and I started asking these questions in a roundabout way. Like it's so stunning to go outside and see the sky, and you can't help but wonder, why is it blue? Or you see pictures of Mars, like you imagine it for the first thing that hits you is how beautiful it is, and that's why I want to put it down. I've made this painting behind me. I go on hikes. I love going on hikes, and I just want to put it down. So I think art came first, and that brought in my curiosity that are more scientific. So that helps me bring all this art to the science.
All right, very cool. And I think that's important too, is that, there's a huge space in science communication for things like art and other spots that maybe people don't think are a part of science. But, just because you didn't study science doesn't mean you can't still be involved and still be a part of science, especially communicating science.
Absolutely.
Okay, Florida. Do we have another question, Florida?
Yes, we do. We have a lot, but we'll ask one. Go ahead, Ben.
How long have you been researching in Death Valley, and how much longer will you be there?
Well, I physically was in Death Valley for about 2 weeks for my field work. That's how much National Geographic paid me to be there. So I would love to go back. And currently, I'm not researching on that area. I do have samples from there. And because we have the samples, we can continue that work. And we also have the chance to expand that work into other places in the US. I am in New Mexico, which is high desert, which also has a lot of dry lakes. So it gives me a chance to extend some of my research here. So maybe Death Valley will be in the near future, but it has taken a little bit of a pause right now.
All right. Mr. Murphy, I see you up at the camera. Does your class have another question?
Yes.
Right. Okay, we're ready for you.
Do you think that life will be found in the water on Mars?
Yeah, I hope so. Yeah, yes.
All right. Well, I mean, there's one thing that we know: where there is water, there tends to be life. So who knows?
Yeah.
And there's a theory as well. There's a few theories for how life originated on Earth. Was it on Earth? But there's one where they think, one theory, maybe it was seeded from Mars, from extremophiles that could have survived that heat and that coldness of space as well, that lack of oxygen. So we still have a lot to figure out, and it's kind of cool that we can explore some of the planets and moons around us to try and figure that out.
Absolutely. That's a great way to put it. Yeah.
All right. Let's see. Miss Forsyth Crew, do you have another question for us?
Anybody have any questions?
No pressure.
It doesn't have to be about science. It can be about art too. I love taking art questions.
Any art questions? No.
All
Just
right.
coming off a long weekend, so.
That's okay. Lots of turkey, I imagine.
Yeah.
Okay, Mr. LaVogue, I know your crew. You said you had lots of questions. Let's wrap up with one more from Florida.
Well, we'll switch it to the art question because I've seen it. I've had a couple kids ask me if Dr. Doss has a website where somebody can look or purchase her art.
Oh yeah, there we do have an Etsy page that is now run by my colleague Tanya Harrison. Because I work for the government, I can no longer sell my art, which is sad. But our Etsy page is called Interstellar. I will share that here. Interstellar Etsy. Here we go. Joe, is it okay if I share my screen?
Yeah, go for it.
All right. Here we go. Share. So here's our Etsy page, and I no longer sell it, but all the artwork is still there that will support Tanya in her endeavors. And if you get a chance to go see that, do. And now that I'm sharing screen, I also want to show you my dress that shoots laser. Can you see it? That's the one that shoots lasers. I was very happy with that. And here's my skirt. That's a galaxy. And with that, I will stop sharing.
All right, very cool. Debarati, thank you so much for being with us today. It's always fun to steal a little bit of your time. It's exciting to see how your career kind of progresses and changes, but you're still very much tied to the Red Planet. And it's great to just let the students kind of go loose with a few questions. So what I'm going to do here, I'm going to squeeze in a question from Isabella is what I'm going to do. Isabella just sent one in from online. What's the best part of your job?
It's the people. It's the people. We're always excited and supportive.
All right. Very cool. Always great to have good people to work with. It makes the workday that much more fun. Classrooms, thank you so much for being with us. There's a few classrooms that have their cameras on, so let me pop them in if they want to do a big wave, a goodbye, and thank you before we sign off for today. Thank you so much for being with us. Thank you for the great questions. Debarati, always great to steal some of your time, and we
Thanks
are
for having me.
sign off for today. Thanks, everyone.